Okay, hi, these are some questions from exercise 7.4. Exercise 7.4 is parabolas with equations of the type y equals ax squared. So here is question 11. It says the curves below are parabolas with equations of the form y equals ax squared, where a is a constant. Now, a could be positive or it could be negative. Okay, we know it's y equals ax squared because the vertex is at the origin, it's at 0, 0. This is also y equals ax squared, but obviously this one's concave down, this one's concave up. Okay, sometimes a can be positive, like in this case, and in this one a would be negative. It says to find the value of a and hence determine the equation of the curve. Now, if we look at this first question here, question 11b, we've got a concave up parabola passing through 0, 0, and it also passes through the point -2, 20. Now, that is an x and a y point. So we know that the equation is of the type y equals ax squared, okay, because it's concave, because its vertex is at the origin, okay. Now what we do, we're going to substitute x is -2, y is 20 into that equation, because we know that the point -2, 20 lies on that particular parabola. So we've got 20 equals a times -2 squared. So we get that 20 is a times, now -2 squared is +4, so therefore wouldn't that be 5 times 4 is 20, so a is 5, just needing a bit more room here. So therefore your parabola will be y equals, we know that the a is 5, it would be y equals 5x squared. So that is the first equation. Now we can do the same thing here with this next parabola. Now we know that this is again y equals ax squared, but we're expecting that we'll get a negative value for a. We're going to substitute in a point that we know, and we know that we've got the point x is -1 because this is an xy value. Y is -2, and we put that in and we get -2 equals a times -1 squared. So I'm substituting for x and I'm substituting for y, and I get -2 equals a times, now -1 squared is 1. Making a the subject, you would divide by 1, but I just get that a would be -2 because a times 1 is a, so therefore a is -2. So therefore my parabola is y equals -2x squared. So that's my answer for that one. Okay. So that is some examples from exercise 7.4. We're now going to do some similar examples from exercise 7.5. Same process, just different type of equation. Now it says here that the curves below are parabolas with equations of the form y equals x squared plus c. So they've been shifted up or down. Or y equals minus x squared plus c. So y equals x squared plus c would be the concave up type. Y equals minus x squared plus c would be the concave down type. Now it says for each curve find the value of c and hence determine the equation of the curve. Now for the first one, this is concave up, so it is y equals x squared plus c. We've got the point here 1, -3, so we're going to substitute x is 1, y is -3 into that equation up there, and we will get -3 equals 1 squared plus c. -3 is 1 plus c, so c will be -3 minus 1, so c is -4. So therefore your equation will be y equals x squared. Now your plus c is, the c is -4, so you get y equals x squared minus 4. Now just having a look at this, does this answer make sense? It is an x squared curve that's shifted down. Now this point here is 1 across 3 down. I know it's not drawn to scale, so therefore what this is telling us is that this point here, the very lowest point of the parabola, so it's just not drawn very well, is this point here is the point 0, -4, or the y-intercept is -4. Okay. Now with the next one, general equation is y equals -x squared plus c for this type. because it's concave down and it's obviously been shifted up so many units, we're going to substitute the point x is 3, y is 5 into that equation. And we will get 5 equals negative. Now only the 3 is squared, not negative 3 squared. It's negative, and then you square the whatever x is. Now x is 3. So you go negative, and then you square the 3, and you get 3 squared is 9. And then we've got plus c. So we've got negative x squared plus c. So we get 5 equals negative 3 squared is 9. So we get negative 9 plus c. So therefore c will be 5. Taking this 9 to the other side, we get 5 plus 9. So c is 14. So therefore the equation is, sorry, just needing a new pen there. The equation will be y equals negative x squared, because this is the type, negative x squared, and it's been shifted plus up 14 units. So it's y equals negative x squared plus 14. Okay, so that's that answer, because we got that c was 14. Now for some examples from exercise 7.8, similar questions, just different style of formula. It says, now these are parabolas of the type y equals x minus h squared plus k. Now we did these in class today. Now it says find the equation of each parabola in the form y equals a x minus h squared plus k. Now if we look at this, it's a concave up parabola. Remember, the parabola would have originally started like this. It then looks like it's been shifted across, and we can see if this is the point down here is -1, -10, it must have been shifted from here across to -1 and then down -10. So if we're looking at a shift, so we've got a shift across to -1, that makes it, now I don't know the a, what it is, because we still have to work that out, but we know that it's been shifted across to -1, which means that I write x plus 1 here, squared. It's also then been shifted down 10 units. So shifted across 1 to the left and then down 10 units. So I go -10. So this is my general formula that I start off with. And I can tell that from the vertex that it was shifted from here, shifted across to -1 and then shifted down 10 units. So now I just substitute any other xy value that I've got. Now here, this is the y-intercept is -7, which happens to be the point 0 across -7 down. So I substitute x is 0, y is -7. You don't go and substitute the vertex back in, because you'll end up with 0, okay? So substituting some other point, which is the y-intercept, which is 0, -7. So I get y is -7 equals a, we don't know, x is 0 plus 1 squared minus 10. So I get -7 equals, now I'll just make some more room here, a times, now 1 squared is 1, so it's just a minus 10. So therefore a is equal to -7 plus 10, or a is 3. So therefore my equation is y equals 3 bracket x plus 1 squared minus 10. Now that's that first example. Now I'm going to look at this second example here. So similar, actually same process again. So we've got y equals a something. Now just think, how did this parabola come about? It's concave down and the vertex is -2, -5. This obviously is not drawn to scale, but to get to that point -2, -5, you have to go across -2 and down -5. So if the shift across is to -2, it's x plus 2 squared. If the shift was over here to plus 2, it would be x minus 2 squared, but the shift is over to -2, so it's x plus 2 squared, because -2 plus 2 is 0. It's then been shifted down 5 units, so we go -5. So that's the general form of our equation, y equals a bracket x plus 2 squared minus 5. You must put this a here. It's really common that people forget to put this, because this lets us work out how steep the graph is. Okay, so now we're going to substitute the point, this other point, as long as it's not the vertex. Substitute the point x is 1, y equals negative 41 into the equation, and we should get that a is negative in this case, okay, because it's concave down. So let's see what we get. Y is negative 41 equals a, x is 1, so we get 1 plus 2 squared minus 5. So negative 41 equals a times, now 1 plus 2 is 3, 3 squared is 9, so a times 9 minus 5. Now a times 9 is 9a, so this minus 5 I'll take over to the other side to make it plus 5. And so I've got 9a is, I think, negative 36, and so therefore a is negative 4. Okay, so therefore your equation is, we substitute the a is negative 4 back up into here, y equals negative 4 bracket x plus 2 all squared minus 5. Okay, going back to exercise 7.5 where we're looking at equations of the type y equals ax squared plus c. Now this question says find the equation of a parabola in the form y equals ax squared plus c given that the vertex has coordinates 0, 7, so 0, 7 would be somewhere up here, and the curve passes through the point negative 1, 3, which would be roughly there. So this is what we've got. If the parabola looks like that and the vertex is 0, negative 7, that's the turning point, which means that my parabola has to be, and it will be, concave down. So we know that the equation is of the form y equals ax squared plus c. So if you plot that point, and that's the vertex, and if it has to pass through negative 1, 3, the only way it can pass is that way, so it has to be concave down. So we know it's y equals ax squared plus c. This is obviously a parabola that was down here in red and shifted up 7 units. So it's y equals ax squared plus 7 is my general form of that equation. I know my a is going to be negative because it's concave down. So now I just substitute a point on my graph, and this is a point here, negative 1, 3. So I substitute x is negative 1, y is 3 into that, and I get 3 equals a times negative 1 squared plus 7. So I get 3 equals, now negative 1 squared is 1, 1a, so I get a plus 7. So therefore a will be 3 minus 7, which is negative 4. So therefore my equation is y equals negative 4x squared plus 7. See, I'm working out the a by substituting an x and y value and then putting that a back in there. So that's my equation, y equals negative 4x squared plus 7. Now for question 12. Now question 12 says, this is exercise 7.5 as well. Sorry, I just jumped around a little bit, but they're all examples, okay? So exercise 7.5, question 12, it says the parabola shown has an equation of the form y equals ax squared plus c. It says form a pair of simultaneous equations and hence find the equation of the parabola. So notice we do not have the vertex or the turning point. We only know that it passes through negative 5, 28 and the point 2, 7. So I know it's y equals ax squared plus c. Firstly, I'm going to substitute in the point x is negative 5, y is 28. And I get 28 equals a times negative 5 squared plus c. And I'll get 28 equals, now negative 5 squared is 25, 25a plus c, I call that equation 1. Then I'm going to substitute x is 2, the other point, y equals 7 into the original equation. I'll get y equals a times 2 squared. Sorry, I know what y is. So I substitute x is 2, y equals 7 into y equals ax squared plus c. And I will get 7 equals a times 2 squared plus c, or 7 equals, now here I get 4a plus c. That's equation 2. So I'm going to come over here now and I'm going to write the two equations together. So we're going to come over here. And I've got 28 equals 5a plus c, equation 1. And I've got 7 equals 4a plus c. Now I'm trying to work out the a and the c. Because I've got two unknowns, I need two equations. Now I can see that the c's have the same coefficient. In other words, the number in front of the c is the same. So to solve simultaneously, I can just do equation 1 minus 2. So I go 28 minus 7 is 21. And 5a minus 4a is 1a. So therefore, a equals 21. Now I've worked out what a is, and I substitute a equals 21 into, just one sec, into either equation 1 or 2. I'll put it into equation 2, and I get 7 equals 4 times 21 plus c. So I get 7 equals 84 plus c. It just seems like a really weird value that I'm getting here. Just something's not looking right. Just one sec. Okay, I found out what I did wrong. So I'll just fix it. Sorry about this. I can see my mistake. All right. I could see I was going to get an answer of negative 70 something for c, which is just ridiculous. I've actually written something incorrectly. If you look over here, 28 equals 25a plus c. So we've got 25a plus c. Sorry about that. But look, we all make mistakes. And the thing is, you've got to realize when you're getting a ridiculous answer to go back and try and find the mistake. So here again, the c's are the same. So I can do equation 1 minus 2. So 28 minus 7 is 21. 25a minus 4a is 21a. So if I've got that 21a equals 21, therefore I will get that a equals 1. So now I'm going to substitute a equals 1 into equation 2, and I will get 7 equals 4 times 1 plus c. So it's equal to 4 plus c. In other words, c is 3. These are much better values. So therefore, my equation, which happens to be y equals ax squared plus c, will be y equals 1x squared plus 3. Now you don't have to write down the 1 in front of the x squared. So we will get y equals x squared plus 3. And that's the answer. Okay? So just being careful there, making sure you copy things out correctly. Okay? And that's that one. Now please, if you could do for homework, exercise on top of what was already given today, exercise 7.4, question 11 C and F. Exercise 7.5, question 10 C, F, and question 11A and 13. And in exercise 7.8, could you please do question 10 C and F? Now those questions are all like the type that I've been doing over the last few pages. Okay, that's it.